begin from our side. A very good evening to all our attendees from across India, and also a good afternoon and a good morning to our attendees from outside of India, wherever you're based out of. Welcome to our webinar on designing safer and lighter buses using high-strength stainless steel. So this is powered by Stalatube, a company from Finland. I would just introduce our three speakers for today before I hand over to David. Firstly, we will have Mr. David Cortés, Export Manager, SBA Transport of Stalatube. Then we have Mr. Lari Brask. Mr. Brask is Development Manager, Technical Support, Welding and Materials at Stalatube. And then we also have with us Mr. Markus Härkönen, Product Development Engineer, Technical Support and Process Industry at Stalatube. Before I hand over to David, a quick piece of information for all our attendees, especially to those who are new to Zoom. After the presentation is over, we will have a Q&A session where the speakers will address some of your questions that you might have. We request the attendees to direct your questions into the Q&A option at the bottom of your screen. So you will be having two options mainly. One is a chat, another one is a Q&A. We request you to direct your questions into the Q&A section so that we can compile the same and share it for response at the end of the session. The chat window is an informal window where you can just share your messages, with the other participants of the webinar. We'd also like to inform that the webinar is also being live streamed on Motor India's YouTube channel. That's just a piece of information for you. So without further ado, I would hand over to David. Thank you.
Thank you, Bala. Hello to everyone, also from our side. And thank you for joining us and having some of your time to listen about our materials and our solutions. So I would like to mention that we will have three polls, three questions during the webinar when we are changing speech. And please, these are specially directed to those working in the bus building industry. So you can also skip them if they are not directed to you. You can just skip them, but feel free also to answer if you want. So this is the structure of our webinar. We will present shortly, although Bala already introduced us, we will show the presenters, brief company presentation. Then we will talk about our company, Stalatube, in the bus and coach building industry. And we will enter into some general information about the duplex and Lean Duplex materials, mechanical properties of Lean Duplex as a material and also as a tube, cutting and welding of Lean Duplex, and then in the end, fatigue strength tests and some design ideas for welded joints and other things. Then in the end, we can see some questions that you may have during the webinar. So please feel free to write them and we will check them at the end. So myself have been recently appointed export manager in Stalatube, and I have 8 years of commercial experience in the transport industry. My colleague Lari Brask, he's our welding material expert here in Stalatube. He has been for also many years working in Stalatube. Markus Härkönen, he's going to be talking about the designing, and he has also experience here in Stalatube for a couple of years. So Stalatube in short, here you can see where we are placed in the world. We are from a company from Finland. We started in '72, actually making kitchen desk in stainless steel, and then this company started to make these square tubes for these kitchens, and then they separated the company as Stalatube itself because the demand started to go up, and they did this strategic decision. During all this time, we have had for a very long time in Holland also a commercial office. And nowadays we have expanded, I mean, we have been in USA and in India since 2009. So we have Tushar Patil in India, who can also talk with you about any of your questions directly there in your country. We also have a commercial office in Germany, and we are actually opening soon a stock in China this year, so hopefully will be operative soon. And we also recently opened a factory in Poland where we are doing those eye profiles and some other products like components and so on. So that's also quite a big change recently for us. We have 130 people working, so we are still a family-owned company, and middle size. Our revenue is at the 100 million level per year, and we do 90% of exports to 50 countries, delivering 28,000 tons yearly, less or more. As you can see below in the left corner, sustainability for us is very important. So 1/3 of our energy needs are covered with solar panels, actually. Our water system is also state of the art, and we use mostly recycled raw materials, and our products are 100% recyclable. So eco-friendliness for us is also a selling point, and that's what we try to do. We have all relevant certificates in the industry for welding, for quality, and for the work safety. So, and we have 3 different industries here. Transport being 1/3 of our revenue, and oil and gas is also an important part. Then we have also stock for stockholders. That's one of the biggest parts of the business. And we try to also get into some other industries like the energy and food processing, etc. These are our main products. So we have mostly square and rectangular tubes in various sizes. We actually have the widest range of sizes in the industry. In stainless steel, everything. And then we have ferritic and duplex tubes are the ones that we sell mostly in the transport industry. We do also laser cut components, as you will see, and we can tailor our products to 1 millimeter precision. So we usually do all kinds of special projects for our customers, and that's where where our strength is, mostly in special projects and also in some bulk products, but especially the tailored ones. We have I-beams, we have also U profiles, L profiles. We do sell some sheets in ferritic and duplex materials also. So feel free to make any requests. Let me show you some of our references in the bus industry. We are the 3rd steel rectangular pipe manufacturer in the world, but in terms of volume, we are the 1st one in the transport industry. So that's very relevant. We are working with the biggest customers. Also with duplex. So companies like Volvo, Scania, VDL, or Solaris are using duplex. Let me talk some history about the stainless steel. It has been used decades in bus building industry. Many don't know this. Volvo was already in the 80s using stainless steel in their buses. but still only about 4% of all buses are made of stainless steel. So there is a lot of space to grow that way. Nowadays, it is mainly ferritic EN 14003 stainless steel, the one that we use. But in the US, for historical reasons, coach builders are also using 304 austenitic stainless steel. Due to weight savings, high strength Lean Duplex stainless steel is getting more and more popular. And actually, one of the trends that we are seeing is that the customers are coming from using aluminum, trying to look for the weight savings. They are now coming to us to use Duplex in their new projects, and we are seeing already results. So that is one big trend that we are seeing at the moment. Let me talk quickly about the advantages of stainless steel. You maybe know stainless steel as a material, but one of the main reasons it is 100% recyclable. It's much better. It has a much better corrosion resistance than carbon steel. It is high strength, which brings opportunity for weight reduction, as well as the capability to use less material in the wall thicknesses. That brings weight reduction. We can achieve lower life cycle costs by using stainless steel. And it has a really good energy absorption percentage compared to carbon steel. We can do custom-made tubes, and it has a great versatility, superior elongation, and longer-lasting attractive finish without any treatments in the surface. So those are advantages of the material. Then, in the materials that we are using in the transport industry are mostly three, as I mentioned already. So we have austenitic, which is used mostly, as I mentioned, in the US for historical reasons. And honestly, we do not recommend to use it. It is expensive due to the high alloy content, and its mechanical properties are not that great compared to other options available. Yield strength, though, it's up to 350 megapascals with our Stala 350 material class. So that is there. Ferritic material, which is the most commonly used stainless steel in the bus construction industry. It has already more than 100 times better corrosion resistance than traditional mild carbon steel. It is cheaper than austenitic, and mechanical properties are pretty good. I mean, the content of nickel is very low, so that also allows us to have a very stable price that doesn't fluctuate so much as it happens with austenitic because of the nickel. Then we do have a yield strength up to 400 megapascals, which is already better than austenitic. So it's cheaper and it has more yield strength. And with our class Stala 400F, we can give you those 400 megapascals. And then the reason for this webinar is to introduce this Lean Duplex material that we have been marketing already for a while, which is now taking over for new projects. It has excellent mechanical properties. Our customers use it mostly for the side pillars and for heavier beams on the body structure that withstand the highest loads in the bus body. We can offer up to a 630 megapascal yield strength, which is much bigger than the others, having still a very good elongation, 20%. And it is our class Stala 630D, the product that we are giving this 630 megapascal. standard yield strength in all the materials is a bit lower than the one that we offer also in tube form. And another advantage of the Lean Duplex, because it's a mixture of austenitic and ferritic, it actually also has a smaller content in nickel, which stabilizes the price. So that is also one of the advantages. Let me show you one component case that we do for Scania. We do this in Europe mostly for factories that they have in Poland and Finland, which are also where we have our own factories. So it is very easy for us to handle logistics. But we are using here duplex stainless steel as well as ferritic. And we are doing tailored solutions, laser cut, ready-made and packed components for final assembly. So by doing this, we are making it very easy for the final assembly employees in our customers' factories. Not to need so skilled force, and it's very practical for them. So in their case, it works very well, and we are here mostly in Europe, price competitive. Maybe in India this way, we are not so much, of course, coming from Europe, but you can see here an example of what we are doing with other customers. Let me show you now an example that you are probably very interested in, an example of life cycle costs, so that you can see, if you check the higher line where we have different materials for a typical bus body structure, which is about 1,500 kilos. So by having a content in duplex for those side pillars and for some of the main beams, you see that the cost is, the purchasing cost is more elevated than those of the ferritic and carbon steel. But we are here avoiding any maintenance due to duplex properties. And then we are also having fuel savings because of the lighter weight. In this case, I mean, this is a moderate and realistic calculation. Much bigger weight savings are possible to achieve, actually. Here we are talking about 150 kilos savings only, but easily we could get more. And what we are theoretically hoping is to soon get even 500 kilos from a typical bus body. So here I have used a ferritic tube price of around $2.25 per kilo. That's the average ferritic price. Lean Duplex here would be around a bit less than $4.50 per kilo. And carbon steel here is thought to be around $1.12 per kilo. Those are average prices that we see in our markets. In option one, we see that the share of ferritic is 1,000 kilos, and then the rest we have duplex. Surface treatment costs are much higher with carbon steel. We all know that. You have to also paint, and it has to be galvanized, and all that adds to the material costs in the production process, which you don't have with duplex, for example. On the other hand, of course, to maximize the weight savings, then you also have to have some costs in designing a new structure, a new design for your body structure. So, I mean, those are costs that, of course, you have to consider as well. But with any new model, we are having these costs. So, repair costs here are considered average for those of the carbon steel. I don't know about your particular market, but this is something that we have got this information from our customers here in Europe. And this is what we see. Diesel price here is considered at $1.35 per liter, about. So we see that savings of 150 kilos only. I remind you that it can be higher in a city bus body, which is what we are considering here in this example. In 100,000 kilometers per year, it means 450 liters of less of diesel and 1,200 kilos less of CO2 emissions annually. So these are big numbers. And when you see this for the typical lifetime of a bus, of a city bus, 20 years, then we can see big savings also in cost when using duplex and ferritic materials together. When talking about electric buses, of course, here we could count, we can see savings as well on energy consumption by having a lower weight. And we can see cost savings on the size of the batteries needed for a particular range that you need in certain model. And in the same way that we are saving fuel in an internal combustion engine, we are here saving electricity and consumption. So those are things that now are especially relevant for electric buses. And with that, I will now give the speech to my colleague Lari Brask. And please feel free now to answer our first poll question. And in a few seconds, we will continue.
Hello, dear listeners. My name is Lari Brask, and now I will tell you something about using Lean Duplex in bus and coach building industry. Okay, let's start from what duplex is. So duplex stainless steel is a mixture of austenite and ferrite. So it is like a composite material. Here in this picture, we have a micrograph of a hot rolled plate. So there we can see that it is a mixture of ferrite and austenite in about equal amount of both. So ferrite is much harder than austenite, but austenite is very tough, and that makes a good combination. So it gives the material high strength and good elongation. And something about the history of duplex, that how did this start? So duplex stainless steel has been used almost 100 years. And in the beginning, they were used mainly in castings. And the reason for that was to avoid hot cracking, and because the standard material was fully austenitic stainless steel, which is very prone to hot cracking. And the main application was oil and gas industry, mainly typically valves. Different kind of valve bodies were casted products. So using of duplex in other products than castings became more common in 1970s when steel refining process had improved enough. And first commonly recognized duplex grade was established. That grade was duplex 2205. It is still the most common duplex grade in the world. And that 2205 is kind of standard duplex still today. And after that, more corrosion resistant duplex grades called super duplex grades has been developed. Now the newest group of duplex grades is called Lean Duplex grades. So these were developed to replace common austenitic grades like 304 and 316. And the reason for that was the high nickel price in around 2007-8, when the nickel price was sky high. So the problem with the common austenitic grades is this high nickel content, which causes prices to fluctuate. These Lean Duplex grades typically have about 2% of nickel, which gives much better price stability. This duplex microstructure also provides much higher strength compared to austenitic grades or ferritic grades. And from this table here, we can see the typical minimum yield strength, which is 480 for both of those two grades, what we are offering. And you can also see that the chromium content is very high, which of course provides good corrosion resistance. And the nickel content is quite low compared to this 4301, which is the standard 304 austenitic stainless steel. This PREN value, the right side, correlates with the corrosion resistance. This comes from the world's pitting resistance equivalent number. So on the top, we have this common ferritic stainless steel grade, which has been used in this industry for decades. Okay, here we have some stress strain curves for three different material groups. This curve for ferritic stainless steel correlates very well with common carbon steel called S355. So from the curves, we can see that the duplex grades have much higher strength compared to the other two, but the duplex grades also have much better elongation compared to ferritic grades. And these properties provide excellent excellent resistance in case of crash. So there is a lot of built-in safety factor in case of rollover accident, for example. This is something what these high-strength carbon steels doesn't have. They typically have very high strength but poor elongation. So in case of crash, there is a risk of cracking. Then something about the Lean Duplex hollow sections. So these products offer possibility to reduce weight compared to ferritic and austenitic stainless steel grades. And this also includes these common carbon steel grades. So the corrosion resistance is much better compared to ferritic stainless steel. And this also concerns the austenitic stainless steel. This Lean Duplex has better corrosion resistance than 304. And this high strength and good elongation makes Lean Duplex an ideal material for rollover structures in a bus body. So that is the main reason why these Lean Duplex grades are being used in bus bodies. And nowadays, the weldability of these modern Lean Duplex grades is also very good, because some of those older duplex grades were very difficult to weld. And then we have the product range for those duplex hollow sections. So the sizes start from 25 by 25 and goes up to 100 by 100. And most of those dimensions are available in this high strength class 630D. And also custom sizes are also available. Here we have some actual tensile test results for those hollow sections. You can see the profile size on the left-hand side. So typically, as you can see, the yield strength is around 700 megapascals. The ultimate tensile strength is more than 900. And still the homogeneous elongation is about 20%. And the elongation at break is always above 20%. It's typically about 25%. So this basically means that these can handle a lot of bending, buckling, all kind of damage before they break. Then we have done some bending resistance tests. Here are some photos from the actual test. And here we have some results from those tests. So there you can also see the profile size on the left-hand side. And there is the steel grade. We had there 3 different steel grades, this carbon steel S355, then ferritic stainless steel, and then 3 different kind of Lean Duplex profiles. So as you can see, the best bending resistance comes from the profile where we have welded together 2 40x40x2 profiles. So you can see that double profile on the right-hand side. So the reason for that is that the side wall in the middle of the tubes prevents local buckling. And just by using two tubes side by side, this 40x40x1.5 has almost the same maximum bending moment as one single 80x40x3 carbon steel tube. So there is a potential weight saving. Then something about cutting and welding of those Lean Duplex products. So Lean Duplex hollow sections can be cut by conventional band and circular saws. High strength of the material may require some special type of saw blade. Stalatube recommends laser cutting to achieve better quality and special shapes, as you saw from the components what we are supplying. Then Lean Duplex can be welded with all conventional welding processes. For cast and coach manufacturing, Stalatube recommends pulsed arc MUG welding. Common welding wire what can be used is called this ER309 LSI. So it is an austenitic wire. So it can be used also for dissimilar welds. So if we have to weld together Lean Duplex and carbon steel or Lean Duplex and ferritic stainless steel. Duplex wire ER2209 is also available. It offers higher strength than the austenitic wire, but it is a little bit more difficult to weld and it has much worse availability. And the recommended shielding gas is argon plus 2% of CO2 or O2. Then we will continue with the fatigue test results.
Because we will have our second poll at this point in time, Markus.
Yes.
Yeah.
I will wait. Okay, I believe all of you have answered already.
Yep.
So good day from my behalf too. My name is Markus Härkönen, and I will talk about fatigue tests that we have done, and also provide some design ideas how to use Lean Duplex. This is the fatigue test setup. What we tested 40x40 and 2 mm thickness tubes to test how good fatigue resistance does Lean Duplex joints of tubes have. And this second picture is about the test results, what happened in the test. So I'm going to show you this because you can see that these welds have not been grinded. So there's still room for improvement. And also you can see the crack initiation point that it's been what is in top of another weld joint on top of each other. So the mechanics of the fatigue crack is a hotspot crack. And so we can use the hotspot calculation in here. So we made 9 tests and made the fat curve based on those. We achieved 150 megapascal class, fat class with 95% certainty, and 165 megapascals with 50% certainty. And the red curve is fat 45 curve, so for comparison purposes. So you need to remember here that we haven't grinded these welds, we haven't used any hammering nor HFMI, so there's still room for improvement. So we achieved pretty good results with that. So what are the design differences with Lean Duplex? We have a material with good elongation, high strength, and good corrosion resistance. So how and where do we use it? We know that we haven't designed a bus, but we know some cases that are difficulties when designing lighter and lighter structures. So those are rollover requirements and fatigue of joints. And when we start from here, from the left, we can use reinforcements from inside of the tubes with inserts. And this is possible because we don't have crevice corrosion, because we have a high corrosion resistance of LDX. If you use this kind of method in carbon steel bus, you will end up with huge corrosion problems. Same thing with tube in a tube setup, that you can reinforce some locations in the bus with another tube because you don't have the crevice corrosion problem. And also tube by tube situation is good, as Lari mentioned, because it increases the buckling resistance of the bus, and the another pipe tube supports each other in case of bending. By the way, the tube in a tube situation is good for Stalatube tubes because we can make tailor-made sizes for the tubes. And lastly, of course, because we have great corrosion resistance, we don't need to make notch holes for hot dip galvanizing of the structures. So there's some design differences between carbon steel and Lean Duplex that you can think about how to reinforce the joints, avoid the fatigue when you are using thinner material. That's all from me. Thank you for listening, and now David will continue.
Okay, thank you. So, well, I just wanted to mention that the fatigue test that Markus was talking about, they were made in IDIADA, in one of the most prestigious European laboratories. So it's not something that we have just done here in-house, but in a certified laboratory. So can we maybe send now the third question, Bala, please? Thank you.
Yeah, it's done. Yeah.
Okay, probably you have all answered already. So we reviewed some of the questions that you made before the webinar. And I would like to point out a few topics that repeated more often. And these are of course cost savings. I mean, we talked already, I think we showed already that our customers can save money, and your customers as well, on the long run by using better materials that allow big savings in maintenance costs and energy consumption costs, be it electricity or fuel for the buses. So this is, I think, already shown. We also talked about weight savings. Typical weight savings are around 200 kilos easily, 300. but we, by applying new design concepts, especially reinforcing those welded joints with the Lean Duplex, it is possible to go to smaller thicknesses that allow those bigger weight savings. And that's what we are now working with some of our customers, creating some concept ideas and new prototypes where we can really bring up the maximum savings by optimizing the design. Especially relevant now with the electric buses. That's something that everybody wants to do. And this is one of the reasons why we are having now more interest in this duplex material. This is a trend, as it has been asked, that what are the trends in the market? And this is one of the trends that we have seen, that there is much more interest now that everybody wants to get some weight savings. And they have seen that aluminum, it doesn't really bring, you need a thicker aluminum to do certain shapes. And in the end, you are not saving that much in a whole body structure. But with stainless steel, we get very good mechanical properties. We don't need any treatments for the tubes, and weldability is good. And we have many good advantages, as we have seen already. Which brings us also to eco-friendliness, which especially relevant nowadays. We showed our compromise already with the environment here in our company, how we get our energy from renewable resources, how our products are 100% recyclable, and how you can save easily tons of CO2 emissions by using a combination of duplex and ferritic materials in the structure of your buses. In Europe especially, and in the rest of the world, showing that your products are eco-friendly can win you a business or not. I mean, more and more cities are demanding now from manufacturers to show their levels of eco-friendliness in their products in bid processes. So at least most relevant in Europe, if you want to win bids, you also have to show how eco-friendly you are. And stainless steel is one big reason to change to this material on top of all the other materials that, all the other advantages that we have seen already. So with that, if there are some more questions, we can try to answer them. What is the situation, Bala?
Yeah, thank you, David, Larry, and Markus. Very nice presentation. I hope the attendees found it informative. Just a quick point before we head to the questions. A copy of this presentation, this is for the attendees, a copy of the presentation along with an entire video recording of the session will be sent to you after the presentation, after the session. So you can definitely carry forward the presentation internally. I think we have a couple of questions from some of them, whether they'll get a copy of the presentation, right? Yeah, so we have a number of interesting questions that are coming in. Yeah, so first one is probably, are there any automotive standards in place for Lean Duplex in bus body construction? This can be globally or anything particular to India, whatever you have to share, David and team.
Please repeat the question.
Is there any automotive standard in place? By regulations, is there anything that regulates the use of Lean Duplex in bus body construction?
I mean, it is not regulated, but what is regulated is the rollover test. And I mean, those you have to be applying to all buses in more and more countries all the time. So the norm was this 55. I don't remember now exactly what was the norm, but I mean the rollover test that all buses have to comply with, especially in Europe. You cannot sell buses if you are not complying with that norm.
Right.
That standard. And Lean Duplex is just a material that allows you to achieve weight savings without compromising safety. So also now I remember that it was fire resistant. Stainless steel in many of their qualities is also, it has a very good fire resistance. So that's another reason to use the material.
Okay. Okay.
And I would like to comment. I would like to comment. Also came to my mind. There was a question about how it is regulated. That how many like new seating places can you add in a bus?
Correct.
Weight savings. So we found that it was every 75 kilos, at least here in Europe, every 75 kilos of weight savings, you can add one more sitting place. So that's one answer to one of those questions.
Right. Yeah, there was a question about seating capacity. Right. Right. Okay.
What else can we?
Yeah. So there was another question here during the session. There was an indication that only 5% of the global bus market, uses stainless steel. One of the attendees wants to know why is it only 5%?
Well,
and just to complete, is it only in Europe where it's predominantly used, and also is it the high cost that kind of prevents it from use in other markets? What will be your view on this, David?
I mean, obviously, in other countries, carbon steel is the king because of the price, because it is around half the price than ferritic, and then duplex is around double the price of duplex. Duplex is around double the price of ferritic per kilo. So, of course, price is one factor that drives this demand. But now when we are seeing that the standards are also getting more and more strict, that you need to comply with those rollover tests, and at the same time you have to do weight savings, then we need better materials in order to achieve that. And for those companies like Volvo, like Scania, these companies that also are working here in the Nordic countries, where historically we have always have road salt, where corrosion is a big problem. In places like Singapore, or where corrosion is a big problem, stainless steel is the only solution when you want to really avoid corrosion problems. Because even with galvanized carbon steel, if you don't take care of the welded joints, if you don't paint well, you can have corrosion problems, and then you have a big problem with your customers. So now it has been a very low percentage, but it is taking over little by little. Mostly it has been price, yes.
Okay, thank you, David. One question which was common by multiple attendees, apart from bus applications, can your product be also used for other applications within the transport sector? In particular, tipper load bodies, can it be used? Also for special tools, and even for lightweight truck bodies. Do you see these as applications? Your views, David?
Well, do you want Lari to maybe answer that question? I will let Lari, which is a more technical person.
Sure. Sure. Yeah, we have a number of technical questions coming in. Maybe Lari and Markus can take it.
Yeah. I wouldn't use this duplex material in a tipper body, because there are better and cheaper materials for that. There are some high strength carbon steels which are better for that application. But if we are talking about the vehicle body itself, some trucks or lorries, yes, and at least here in Europe, there has been some tankers, road tankers made of Lean Duplex. So they are much lighter, and if they are transporting some chemicals which are corrosive, then they have also made a chassis out of Lean Duplex.
No, thank you, Lari. A few technical questions. I'll probably get them one by one so that Lari and Markus can take them. Has FEA analysis been done for your duplex stainless steel?
Sorry, now we couldn't hear you. Please repeat.
FEA, that's a finite element analysis. Has it been done for, yeah?
Yes.
Okay, okay, right. And also, there was a question, I wouldn't want to name the competing brand, but how does Stalatubes compare with those from other grades of duplex steel that are probably available globally and also in India?
We don't know about that, but we haven't seen a lot of competition in this sector yet.
Okay, okay, right. And also another common question is, what are the changes in terms of welding and other processes, like, in terms of bending, cutting, welding, grinding, painting, all these processes, what kind of change in machinery, change in tools, and also change in manpower would be required when if suppose a customer wants to switch from carbon steel to stainless steel?
Of course, it depends a lot from the level of equipment and the technology which is already existing. So if a company is used to use some cheap carbon steel, then the step is of course quite big. Naturally, because this material is much stronger, it needs maybe a bigger bending machine, and it's like I said, maybe they have to update the cutting machine, things like that, and maybe I would guess also welding machines. Of course, there are a lot of things which might require some updating. But what comes to manpower, I don't see a big difference there.
What about in terms of the skilling of the manpower? The same skilling is sufficient, or do they need to be upskilled?
Of course, they need to practice that a bit. The welding is not the same, but if a person can weld carbon steel very well, it's not a big step. It's just mainly changing the filler wire and the sealing gas. That is the biggest thing.
Okay, right. And how would duplex stainless steel compare with FRP and GRP composites, Lari?
Of course, the composites are very light, but as far as we know, it's still impossible to fulfill these R66.2, these rollover requirements with these composite materials, because they doesn't absorb energy. That is the problem. But the steel has this kind of all the metals have these unique properties of energy absorption compared to these plastics or composites.
Okay, right. There was a mention about the corrosion problem in the Nordic regions and also in parts of Europe. But when it comes to the Indian context, probably the levels of corrosion are a little different. So how would the high initial cost of duplex stainless steel, how would you justify the overall benefits over the long term, since the corrosion is not a big challenge compared to European markets?
That is a really good question, but I suppose that the coastal areas of India are also quite tough places, because there is high temperature, high humidity, because of course we have, for example, customers in Thailand, and they have had some serious corrosion problems there. I don't think the climate is so much different. But still, how do we justify the much higher price? That is a good question. But then if you can at the same time also save weight, then maybe in that case that the total cost can be justified, or if the vehicle has longer lifespan or can carry more passengers or things like that.
Okay, right. There's also a question asking whether is it possible to mix stainless steel and carbon steel based on right stress levels, and will that be possible? What are the pros and cons of the same?
Yes, we have customers who are doing that. They are mixing carbon steel and stainless steel together, and then of course there is some kind of risk of galvanic corrosion, but because they have to paint the carbon steel parts anyway, so they should be safe, but there is a potential risk that if the protective layer of the carbon steel is damaged, that there will happen some galvanic corrosion between the stainless steel and carbon steel.
Okay.
But,
Okay.
but of course, almost all chassis which are commercially available are made of carbon steel, so it cannot be completely avoided.
Right. Right. Okay. And is Lean Duplex a patented technology from Stalatube?
No, it's not.
Okay, it's available otherwise, right? And also from a market perspective in India, what is Stalatube's current presence? Do you already have anybody who's using any of your products in India? And if somebody wants to try out your products, what will be probably the delivery timelines and all those? Can you give some information? Some of the customers are probably interested in knowing that.
Do you have, David, better knowledge?
Well, I've been, I mean, India is under my supervision now for 1 week. So I'm still learning about the market and the customers, but I mean, we are working with Daimler, we are working with Volvo. I don't know to which extent they already have models, maybe with stainless steel. That's it's difficult to say, but the same companies do have in other markets these materials. So
Okay.
It's hard to say.
Right. There was a case study or a comparative study between different materials for a city bus application. How would your product fare for other applications within the bus sector? Like, for instance, premium coach, also tourist buses. Would it make sense there as well?
I mean, of course, I forgot to mention that in coach, of course, you can get even bigger weight savings because the body is heavier in the coach. So the heavier the body, the more potential weight savings you can have by using a combination of duplex and ferritic stainless steel, for example. If you use only duplex, I mean, you can do it, and then you would have a great bus. But of course, price-wise, maybe it's not so necessary to do the whole body. But for the main parts, trying to optimize the weight saving in those tubes that are thicker, trying to minimize that thickness, it is then worth in coaches, you can save. In the railway industry, we are also selling, it is not our main sector, the bus industry, it's 95% maybe of what we do here in the transport department. But we are also selling to trams and to locomotives. They are using components with duplex in various grades. So applications are many.
Right. Okay. There's also a quick observation from one of our attendees. He says Stalatubes were used for the Bombardier metro cars made in India. So as you rightly said, I think that's another application where probably in India already they're in use. That's one thing.
Myself, I have it is in Metro India. Lari's telling me that yes.
Yes, I think he's just given an observation. Yeah.
Bombardier is one of my customers. Me, I'm still learning about the different customers and what we have done in the past.
Right.
Yes.
Right. Okay. There's also another question. How does the duplex solution compare with the CRCA tubes, cold rolled close annealed tubes with anti-rust treatment? How does it compare?
Lari?
Unfortunately, I don't have the mechanical properties of those carbon steel tubes, so it's difficult to say. But like I mentioned earlier, that the carbon steel tubes, what I have seen here in Europe, they have very high strength, but the elongation properties are quite poor, which means that in many cases they cannot be used in these rollover structures because of the limited elongation. So that is one limiting factor for using these high-strength carbon steel tubes.
Okay. Yeah, we'll probably have a few last questions. Where are your steel products made? Are they produced in bulk under one facility? Can you give some details about the same?
Yeah, sure. I mean, we have actually one video. We will send a link together with the presentation in PDF. So our main factory is in Finland,
okay,
where we are doing all the tubes And then in Poland, we just started production this year. And we are doing profiles and components. So we are processing the tubes we do in Finland, in Poland, with laser cutting, bending, and then we do there the I-beams and LU profiles and other products. But Finland is the main factory.
Okay, right. Okay, couple of last questions. 1 minute, just getting. Yeah, just some of them want to know a percentage-wise reduction in weight, you know, on an average for different applications within the bus sector. What will be the percentage-wise reduction in weight and also the percentage cost savings over a period of time? If you can give a timeline as well, David.
The timeline? Well, that depends on everybody's designing team. I mean, the percentage of reduction, I was talking that in a 1,500 kilos bus, typically made of carbon steel or ferritic stainless steel, which is pretty much the same weight, you can maybe save 150 kilos. So what is that, around 10%?
Okay.
But depends, that's in a city bus in that case. If we go to a coach and then we have even also we count the chassis and we have 2.5 tons in total for the chassis and the body, and we can save up to 500 kilos by doing all reinforced joints, and we can achieve even, maybe it could even be more. Then of course it will be a bigger percentage. That depends now on the design and who is ready to try, because the problem with the technology with welded joints hasn't evolved. That's the thing with buses, that the technology of welding tube to tube, that hasn't changed much. So that's what we are now trying to bring to the table, we are convincing big customers now to do prototypes. So we will know much more in 1-2 years time. We are already doing fatigue testing, and we are trying to do that also by ourselves with our resources, trying to prove that you can really do those 500 kilos, maybe even more. But of course, at this stage, it's all those manufacturers also keep confidentiality of their own designs, and it's not possible just today. It's not figures that they would share easily. The duplex that they are using on this. So, but depends on your design.
Right. Okay. Right. We'll probably end this with one last question. Technically, there are also some questions, David, on what is the minimum quantity order and all that. I would let you probably take it individually with some of the attendees, you know, post the session. One technical question with which we'll probably wind up. How is the heat affected zone in Lean Duplex compared to carbon steel? It's a technical one.
Yes, it is. Lean Duplex is actually much better material in that way, because already in annealed condition, it has about the same mechanical properties as a tube. So what happens for high strength carbon steel tubes, because those are hardened, and what happens is that it becomes much softer. The heat affected zone represents like an annealed material. So there is a kind of a weak spot next to the weld in this heat affected zone. So that is something that Lean Duplex grades doesn't suffer from.
Okay, and probably one more. Are you looking at developing a bolted body construction system?
We don't have that kind of plans at least yet, but that's a good point.
Okay.
Just quickly about the minimum deliveries. I mean, we are delivering to 50 countries. We are delivering even to China, to Egypt, to USA, Canada. I mean, typically you want to fill in at least one container. Otherwise, I mean, you can order less than that, but it's going to cost more. So if you can get one container, we can send, of course, at the beginning samples. We like to work with our customers develop those projects. We also invest, I mean, in that. We try to support our customers as much as possible. So samples are sometimes possible. We can maybe put together different orders if time waiting a bit, it's not an issue for those prototypes. And I mean, there are ways to start small and then wait for bigger volumes. But one container typically is what you want to try to fill in, at least to optimize the cost of transportation.
Right. Okay. Great. So some more questions on specific test values, test results, and all that. Thank you so much, attendees, for all your questions, for your interest on Stalatube and their technology. We'd let David and his team reach out to you after the session, and feel free to write to them for any questions. Feel free to reach out to us in case you have any questions from our side as well. And as indicated, you will receive a copy of this presentation along with a video recording of the entire session for you to go through and also share it internally with your teams if you wish to take it forward from here. So from my side, thank you very much, David, Larry, and Markus, for your time and for presenting. Yeah. So until next time, thank you and goodbye to everybody.
Thank you, Baran.
Thank you.
Thank you for everybody for the time. Bye-bye.